Heating and air conditioning service. In the 2 previous videos in this series, you learned how heating and air conditioning systems operate. You studied fundamental principles and the theory of a refrigeration cycle. The second video detailed how to diagnose common problems. It explained how to find system leaks, how to use a gauge set to complete a performance test, and also discussed how to do other basic troubleshooting operations. This video will build upon this training by discussing how to service major heating and air conditioning components. You will learn how to use various specialized service tools to make yourself a more competent technician. Warning: refrigerant R12 or Freon is dangerous. Not only can it cause severe frostbite to human tissue, it is also harmful to our atmosphere. Never allow refrigerant to escape into the atmosphere. Always use a recovery station to retrieve, store, process, and recycle Freon. A recovery station will pull the old refrigerant into a storage tank. The station can then filter moisture and other unwanted debris out of the old Freon and ready it for recycling in another car's air conditioning system. Recycling is also desirable from an economic standpoint. Refrigerant is expensive. By using it over, you can save the shop considerable expense. Recycled Freon is basically free once the recovery station has been paid for. To use a recovery station, connect it to the car's service fittings directly or through your gauge set. Connect the center yellow service hose to the station. Open both valves on the gauges so that the system refrigerant can flow into the center hose and to the station. Plug the charging station into a wall outlet. Then turn the station pump on so that it can pull the old Freon out of the vehicle's air conditioning system. Since charging station operating instructions vary, always refer to the manufacturer's directions for a specific piece of equipment. Generally, set the controls to recover. Then energize the pump motor. A high-pressure tank is used to hold and store the recycled refrigerant. High-pressure hoses lead to and from this tank. The charging system will purge the Freon out of the vehicle's air conditioning system. It will pull the Freon through the manifold gauge set, through the hoses, into the station, and then down into the high-pressure storage tank. The station will often signal when recovery is completed. Complete recovery can take several minutes. Generally, recovery is done when your manifold gauge set shows a vacuum. Most stations will pull between 15 and 20 inches of mercury. It is up to you, the automotive technician, to protect our planet from further damage and global warming caused by the tons of Freon dumped into our atmosphere. Internal compressor parts can wear and fail, causing abnormal noises and unacceptable test pressures. A leaking front seal is a very common trouble due to the constant rotation and friction of the compressor shaft. A bad clutch coil can keep the compressor clutch from engaging. The coil windings can break open from the vibration of the compressor, or they can become shorted. Each can prevent the magnetic field from engaging the clutch. The clutch plate and pulley can also become worn and loose after prolonged service. If the compressor fails to turn on, first check that the voltage is being fed to the compressor coil. Use a voltmeter or test light. If you are not getting voltage to the compressor, trace back through the circuit. If you are getting voltage to the compressor, use an ohm meter to check the coil windings for opens and shorts. These are the two coil terminals where you would connect your ohm meter for testing the coil. With internal problems, most mechanics install a new or rebuilt compressor. To replace a compressor, simply loosen and remove the belt, wires, hoses, and the bracket bolts. This will let you lift the bad compressor off the engine. A few older compressors can be equipped with hand valves like this one, instead of a more modern spring-loaded Schrader-type service valve. It has a hand screw that can be turned into various positions. To connect your gauge set to this type valve, remove the protective caps over the service fittings. Also, remove the caps over the valves. Install your test hoses on the service fittings. Then rotate the hand valves into the desired position. You can use a ratchet and socket or a special wrench. When back-seated, the service port is closed off. The refrigerant can flow from the compressor to the system. This is the normal operating position for the air conditioning system. The hand valve is rotated all the way out. When in mid-position, the valve opens all of the ports. This allows you to check system pressure with the engine and the AC system in operation. Pressure will flow out of the service port to the gauges and through the system. When front-seated all the way in, the AC system is isolated from the compressor. This will let you remove the compressor without losing all of the freon in the car's evaporator, condenser, and lines. Only the freon in the compressor will be lost. Some compressors have a sump, and they must have their oil level checked during service. To check compressor oil, remove the plug or designated bolt on the compressor body. Then use a handmade or factory dipstick to check the oil level. This is a factory or aftermarket dipstick. Insert the dipstick through the hole and down into the sump of the compressor. Remove the dipstick and observe the oil level. Refer to the service manual for the exact levels and the amount of oil to install in the compressor. Next, we'll show you how to service a compressor front seal. Special tools are needed to drive off the compressor plate and the seal. First, screw a special driver into the compressor front plate. Then, use 2 wrenches to tighten down the puller bolt. This will force the plate off the clutch pulley. As each part is removed, inspect it closely for signs of wear or damage. Use a pick to pull out any felt oil wick, like this one. It helps catch any compressor oil and keeps dust and dirt out. Use snap ring pliers to remove the snap ring securing the front seal into place. Next, use a special seal puller to grasp the front half of the seal and pull it out of the compressor. Use another special tool if needed to grasp and retrieve the other half of the compressor shaft seal. Note that the tools vary with compressor designs. This tool grasps and holds the rear half of the front seal. Use your pick to remove any O-rings installed around the outside of the compressor seal. Coat all new parts with refrigerant oil, then reinstall the parts in reverse order of removal. First, work the new O-ring seal down into its groove. Push the seal into place. Then, use your pick to force the seal down into its groove. Slide a protector over the compressor shaft to prevent damage to the delicate compressor seal assembly. Then, use your seal tools to slide the new parts into place. Avoid touching the fiber part of the compressor seal with your hands because acid on your skin can etch the seal. Use a tissue to pick up and handle the fiber compressor seal. Again, be extremely careful not to nick or scratch the new seal or it will leak. When installing the snap ring, make sure the flat side of the snap ring faces outward or away from the seal. Again, always refer to a factory service manual when working on a compressor. Procedures vary with a specific make and model. When installing a compressor on the engine, make sure you use new O-rings if needed. Coat them with oil. Install the bolts and brackets that hold the compressor on the engine. Tighten down the refrigerant lines. Connect the wires to the compressor clutch coil and to any sensors. Adjust belt tension, then tighten all of the bracket bolts completely. Accumulator problems sometimes occur. Restriction in the accumulator and desiccant failure and leakage are the most common sources of trouble. When restricted, the accumulator will often frost up. A bad receiver dryer can also affect system operation. It can become restricted, or the desiccant agent can become contaminated. Either would require replacement. To replace an accumulator, disconnect the wires going to any sensors. Then, use 2 wrenches to unbolt the 2 lines leading into and out of the accumulator. 2 wrenches are needed to prevent fitting damage. Normally, you must add a recommended amount of oil to the new accumulator. Refer to factory specs, then pour the recommended amount of oil directly into the new accumulator. Then, install the accumulator in reverse order of removal. Make sure all fittings are tightened down and do not leak. Orifice tube problems are fairly common. Clogging is the most common reason for orifice tube service. The O-rings around the outside of the orifice tube can also leak. Physical damage is common when technicians try to remove the orifice tube unsuccessfully. Any of these problems would require you to remove and replace or clean the orifice tube. Use 2 wrenches to unscrew the fittings covering the orifice tube. Pull the line out of the way and push it to one side. Next, use an orifice tube removal tool to grasp and pull the orifice tube out of its line. Note the special prongs on the end of the tool that grab tangs on the orifice tube. Slide the tool into the line and then turn it about 1/4 of a turn. This will lock the tool onto the tangs of the orifice tube. Pulling straight out will normally free and remove the orifice tube. Remember, slide the tool in while rotating it, then pull out once the tangs have been locked into the tool. This orifice tube is badly clogged with debris. It resulted in insufficient flow through the system and poor cooling. Slide the new or cleaned orifice tube back into place, then install the line. With this design, the line itself will push the orifice tube into place. Use a new O-ring on the line if needed. Hand start the fitting to prevent it from cross-threading. It is very easy to cross-thread and damage fittings. Expansion valve problems are also fairly common. If an expansion valve is stuck open, excess Freon flow through the evaporator can cause the evaporator to freeze up. Ice or frost can form on the outside of the evaporator, which prevents normal airflow through the outside of the evaporator. This can prevent cool air from entering the passenger compartment. In another extreme, the expansion valve could stick closed or partially closed. This could restrict or prevent normal flow through the system. Another common problem is the expansion valve bulb is not contacting the line on the output of the evaporator normally. To service an expansion valve, you must normally remove the insulating material around the outside of the valve. Use a knife to cut away this material and free it from the expansion valve. Then use your 2 wrenches to unscrew and remove the expansion valve. Normally, a small clamp secures a sensing bulb to its line. Removing the small screw will free the clamp and the bulb for expansion valve replacement. Install the new expansion valve in reverse order of removal. Condenser problems are often caused by physical damage from an auto accident or road debris flying up and damaging the condenser. Pinhole leaks can also develop in the condenser, allowing the escape of refrigerant. A restriction in the condenser is a less common problem that can prevent normal cooling. In any case, the condenser would have to be removed and replaced. Evaporator problems typically are caused by leakage. Again, corrosion can cause the evaporator to begin to leak. In some rare instances, the evaporator can become restricted, preventing normal refrigerant flow. To replace a condenser, first remove the lines going to and from the condenser. Use 2 wrenches to prevent fitting or line damage. Then, unbolt and remove the bracket bolts that secure the condenser to the vehicle. Sometimes you must remove the engine radiator first before you can remove the condenser. Refer to your service manual if in doubt. Most technicians always replace a desiccant whenever a major air conditioning system component is replaced. If you discover an evaporator leak or other problem, you must remove it from the vehicle. This can be a very time-consuming operation, taking 6, possibly 8 hours of labor. You must disconnect the wires and hoses leading to the evaporator and related components. Then, you must remove small screws and clips that secure the housing to the vehicle and to the evaporator. This will allow you to lift and separate the housing to gain access to the evaporator. Sometimes the evaporator and housing are serviced under the dash. Sometimes the evaporator must be serviced on the outside of the firewall in the engine compartment. Again, your service manual will give directions. When replacing the evaporator, use new housing seals if needed. Here is a close-up of small clips that secure the halves of the evaporator heater core housing. A screwdriver will pop these clips off. Numerous small screws, some very difficult to reach, also secure the evaporator and heater core housing to the vehicle. Once all of these fasteners or clips are removed, the housing can be separated to gain access to the evaporator. Install all components in the opposite sequence of removal. A common problem is a clogged drain on the evaporator housing. Whenever you find moisture collecting on the floor of the car or on the carpet, check for a clogged drain. System evacuation is done for 2 reasons: to check the repaired system for leakage before charging, and to purge air and moisture from the system. A vacuum pump like this one is used to evacuate the system. Evacuation is recommended anytime the system is open to the atmosphere and before recharging with Freon. Attach the yellow hose from the manifold gauge set to the vacuum pump. Open the low side gauge valve. Plug in and turn on the vacuum pump. Allow the pump to run and pull vacuum until the low pressure gauge reads approximately 25 to 30 inches of mercury. Charts are available for exact vacuum specs for different altitudes. After reaching the recommended vacuum, run the pump another half hour or so to assure complete removal of air and moisture. A charging station can also be used to evacuate the air conditioning system. Connect the charging station to the service fittings on the vehicle. Then, set the station controls as desired. After reaching the required vacuum, run the pump another half hour to assure complete purging. After evacuation, observe the pressure gauge reading. If the vacuum drops, you have a leak that must be repaired before charging it with R12. To charge an air conditioning system, you must inject the recommended amount of refrigerant into the system. You can use small 1-pound cans like this one, or larger tanks. Normally, charge the system through the low side until vent air outlet temperature reaches specs or about 34 degrees Fahrenheit. Keep the can right side up to prevent liquid refrigerant from damaging the compressor. You can place the cans in warm water to speed charging, but do not overheat the R12 can or it could explode. Now we'll show you how to charge a system using a large R12 tank and a weight scale. Connect the tank to the weight scale or automatic charging unit, or directly to the gauge manifold set, depending on the weight scale design. Refer to the instructions for the specific type of unit. Procedures vary. Make sure the tank is centered on the scale. To utilize this specific programmable charging meter, turn the unit on, then press the button to zero the digital display. Once zeroed, this unit allows you to set the amount of Freon to be added to the car's air conditioning system. Other types of weight scales simply show how much has been added in pounds and ounces. Open the center gauge valve and the low side gauge valve. Also, crack open the gauge hose fittings to remove air from them before charging. With automatic metering, the unit will shut down when the preset or programmed charge is reached. With other scales, you must close the gauge valves when the scale reads the correct charge has entered the system. When the gauge valves are first opened, the vacuum from the evacuation will suck in a large amount of refrigerant from the tank. After pressures have balanced, start the engine and set the air conditioner controls to max cooling. Compressor action will then pull the remainder of the charge into the air conditioning system. A charging station provides an even more efficient way of working. It will automatically evacuate, add oil, and then charge the system with a recommended amount of refrigerant. It houses large tanks of oil and refrigerant, solenoid-type flow control valves, and an internal pump for automatic charging. First, set the controls on the station as needed. Dial in the amount of oil to be injected into the system. Then, set the dial to add the correct amount of refrigerant. Press the start button, and the station will meter the correct amount of oil into the system. Then, the charging system will slowly add the set amount of refrigerant. A sight glass is often provided on the station to show you the flow of oil and refrigerant out of the station to the vehicle. Pressure gauges on the station will let you performance test the air conditioning system and check your repairs. Double check high side and low side pressures, and also measure the vent outlet temperature in the passenger compartment to assure adequate cooling. Heater problems are relatively easy to diagnose and repair. The heater core is the most common source of trouble. It can corrode and begin to leak, or it can become clogged and restrict flow of hot coolant. The heater hoses can also deteriorate and leak. The heater valve, in series with the heater hoses, can fail to open and close normally. To test the heater control valve, connect a hand vacuum pump to its diaphragm. Pump the handle and observe the action of the valve. It should open and close normally, and the diaphragm should not leak vacuum. If needed, also check that a supply of vacuum is being fed to the valve. Install your test hose into the vacuum line leading to the heater valve. With the heater on, your vacuum gauge should show spec engine vacuum. If you are not getting a source of vacuum to the heater valve, trace back through the vacuum lines to find any leaks. Look for deteriorated or disconnected vacuum hoses. Finish testing for vacuum at the control head in the dash. Sometimes you can fix the clogged heater core by flushing it. Use a garden hose or pressure flusher like this one to force water through the core. This may remove rust and other debris that prevents normal flow.